So I don't know where to put myself, but I think I will stay here. Thank you very much for having me to NTNU, and thank you, Jon, for the organization. First of all, I would like to thank my dear colleague and dear friend, Letizia Iaccheri, for nominating me for the honorary doctorate I'm about to receive. She's a role model in our community for many of us. And also I would like to thank, I'm going back and forth, to thank the fellow PhD student in the winter 1994, like for instance Ger, that helped me integrate in the research group of Radar Conradi. At the time we didn't know that we would meet again after about 30 years, but this was a milestone for me and for my research. When you go home, I would like that you bring home and reflect at least on three points, three takeaways. First, the software can help or hinder sustainability. When we think about sustainability in software, we think a lot about the benefits and we forget about the possible drawbacks and the risks. So we should balance them and address them explicitly. Second, that decision-making must be informed. We take a lot of decisions in the digital solution we inject in our society, which are biased and which are based on beliefs. So well-informed decisions are crucial in general and specifically in a more sustainable society. And third, that we need a mix of education and training, higher education for the new talents and trainings for existing practitioners that have to contribute their own experience. I will come back to each of these points in my presentation. So about software sustainability, maybe a general setting the floor. If we look at the literature in software engineering and software sustainability, I recognize, first of all, that there is by now a lot of literature in the field, but most of the literature either don't provide clear definitions of what software sustainability means, and also most of them, if they use a definition, they use the definition borrowed by the United Nations Brundtland report, which is about sustainable development, which is not always fitting, so we tweak a little bit this definition too much. In the direction of a better definition, we should consider that it is important for true sustainability to think about the time scale, and consider the effects on a longer period of time. And the third aspect that a good definition should include is that sustainability is not only about, for instance, ecological impacts or the economic revenues, is multidimensional. And not all dimensions are equally important for all types of softwares or all types of digital solutions. So I don't want to go too much into this, but I tried to patch a possible definition which is better encompassing, which for me is important, that is addressing both the long-term effects and the beneficial uses for the specific context, but also it's somehow accommodated continuous change, because our society changes, we change ourselves, and the solutions should reflect this. So there are many perspectives. I'm sure everybody of us knows at least one or multiple of them on sustainability in general. I think that there are two specifically that are really pertaining software, and my research is more related to software architecture, so how we structure software-intensive systems. But I use, for instance, the dimension of focus. Let's see. Well, you don't see that, on the left-hand side on the bottom, which is inspired by the people, planet, and profit, which is historically going back to a certain definition of sustainability. So we have the equivalent economic aspects, social and environmental, and of course the technical sustainability, because we are talking about technology after all. So these are the dimension of focus that we consider often in research. And in the middle, you have what is called the order of impacts, which is the time scale, basically, in which we consider if a certain solution has a direct impact. For example, when we build data center, they consume electricity. So the solution itself, the data center, is directly impacting energy consumption. But also enabling impact, which is the processes that, for instance, a data center can support. So it supports us to access our data and our services, our application from anywhere, anytime. And this allows us to be more flexible in the type of work that we want to do. And this flexibility can inject the systemic impact, which is more about behavioral change. So because we can access from anywhere, anytime, then we can also change the way we balance, for instance, quality of life and work effectiveness. Or less balanced is also a choice. And last, the rebound effects, which are typically considered negatives, but can also positive, which is when there are unforeseen effects, so unplanned. Like for instance, if we have a more energy efficient digital solution, we aim to decrease its energy footprint, but because it's more efficient, we might tend to use it more or more frequently, which has the counter effect of increasing the footprint. So being mindful about the plans and the actual effects of the achievement or not of this plan is what sustainability is about, I think. When we talk about software, we mapped this into versions, if you wish, inward looking. So we look at the technology itself, so the direct impact, and we call about sustainable software, but also outward looking, so the indirect impact. And in the first case, we talk, for instance, typically, an example is energy efficiency, but in the second case, we look at the processes again that software supports, like for instance, digital inclusion. Because we are more and more digitalized, then we have also to see if the processes that we digitalize are inclusive of all target populations, target users. So this is software for sustainability goals. So this is the two aspects. To fix ideas, I like the example of the drones. Drones are mobile devices that have a battery, and when the battery is finished, the drone falls. So inward looking, a drone, for instance, should be technically sustainable. We have to optimize a piece of software to fit in the mobile device. Also environmental sustainable, consume as little battery as possible before the drone falls. But outward looking, there are many different uses on different sectors of drones or robot technologies. For example, social sustainability is the use in healthcare, just as an example, that the drones can be used to bring medicine or provide healthcare in remote locations, so that the people anywhere in the world can be healthier, and from the economic perspective, can be also more affordable. So this is a promise. We put a lot of technologies in the field with this type of promises, but we not always actually measure if these promises are being achieved. On the time scale, again, I use the same example. So we talk about the first order effect, the impact, the draining or not draining the battery before the time of the mission of the drone. The indirect impacts of supporting, for instance, healthcare anywhere in remote locations or in case of emergencies, so supporting these processes. But the systemic impact is this behavioral change that, for instance, thanks to the use of the drones in healthcare, medical doctors have to acquire different type of competencies to provide their own services. Education changes because we have to train and educate all these people, as well as the people that are with the patients remotely. We have different type of professions potentially that could be created thanks to the combination of humans and the technology. So this is type of behavioral change which is intersectoral and will change the way we change, in this case, the technologies that we support, so the ICT sector, the healthcare sector, and also the educational sectors. So after this premise, I see a number of challenges, and for me, challenges are also opportunities. The first of all, we saw these definitions, and I think that the main challenge for research is to not only focus on the dimensions of focus, but also address the time scale. And most of the work forgets the second. So representing time in software engineering and ICT in general, I think it remains a huge challenge. Only when we focus time, we can really talk about sustainability. The second is more related to the work in architectures. So historically, we talk about software architectures with the use of technology more and more intertwined in society. The boundary between digital and physical is less clear, so it's more tight, is tied together. And then we have started a few years ago to talk not software architecture, but digital architecture. And in one or the other, we tend as computer scientists to focus on the system, so how we design and develop and evolve the system, and we forget about the context of these systems. And by the way, I think the same mistake is being done in artificial intelligence. This is a bit overlapping, doesn't matter. So I see at least three type of contexts that should be modeled explicitly when we develop this type of the architecture of the systems. One is the organizational context, and I see the change between the evolution from traditional enterprises, traditional organizations, to communities. And in doing so, the social aspect, social sustainability, is becoming more and more of a challenge, because not only the way organizations work, for instance, they develop software projects, they don't engage different type of communities that are the users in our society or the using organizations. So they have to change totally the way they develop technology, which means, for instance, agile methods have to change fundamentally, and the way the organizations work have to change fundamentally, as well as the way we represent quality of software-intensive systems. We think about performance and energy efficiency, but we don't think about the intrinsic values that these systems have to support in our society, like, for instance, creating trust. The second type of content is the domain or the specific sector. So there is the shift between predefined contractual partnerships to more dynamic, more flexible interactions across different sectors. We saw the example, the systemic example before with the drones and healthcare. So we assume in sustainability that technology is able to accommodate extreme flexibility, and it is not. So how can, again, technology be more flexible so that these interactions and the benefits are brought in society, but also to the different sectors? And at last, the business context. Many organizations still think in terms of economic revenues and try to adapt a little bit, integrate a little bit of sustainability, because nowadays it is demanded. And the real innovation comes from thinking about how the business model is changing to, yes, bring also economic revenues, but address economic goals. And I believe that only organizations that are really to innovate thanks to this the energy crisis will be the most successful. And further, last challenge for this part, for me, is on how we activate sustainability-aware architecting, but in general, software engineering. Activation means how to trigger this type of change. And there are, I think, two dimensions that help activation. One is embracing different types of stakeholders. In software engineering, we think historically mostly about the system users or using organizations. So we define the requirements that we should fulfill, and the development organization, which are those that develop the system following these requirements. But there is a third type of stakeholder, which are the indirect stakeholders, which don't interact directly with the system, but they are influenced by the success or failure of these systems. It is much more challenging to engage these indirect stakeholders or include also their needs in software engineering. And if we don't do that, they will be excluded. And the drivers for activations, you see this is a quite recent report from Gartner. There are many examples like this that show that there are the main drivers for sustainability are both bottom-up, so the consumers or the consuming organization. And in software engineering, I think the challenge is to provide like what we call labels for digital solutions, like measures that tell the consumers the level of sustainability of that applications or their solutions if you use that. And there are many apps, for example, that are required, but one is consuming less than the other, one is more inclusive than the other. And top down, we have the real decision makers, like the governments, like the standardization bodies, that also can help in creating this, activating the organizations to invest in sustainability. And then in both cases, we need not only simple measures and indicators, but also the significant ones, those that really trigger a change. In order to start supporting better informed design decision making, we developed in our research for a number of years what we call the Sustainability Assessment Framework Toolkit. This is a set of tools that we share open source, open access, that would help organizations, but also students, to start thinking in terms of sustainability. On the right-hand side, you see a number of instruments. I don't enter the details, but these capture the know-how that we develop in multiple projects over time. And these are used to produce the two artifacts on the left-hand side. The one is the decision map, which is a very simple view on the features of a software system and what are the concerns, so the quality properties that matter for sustainability and how they are interdependent. And the second one is a quality model called Sustainability Quality Model, which is basically providing the definition of all these concerns and the metrics that are associated with this definition. And if you have the two things, you have a view that helps you designing, making decisions, and monitoring the measures. And the other is a kind of standard that you can use in your internal organizations or in a specific application domain. Here I have a very simple example that we are all comfortable with, conferences or information events like this. So you see in this example that, for instance, if you want to reflect on this level of sustainability of on-site conferences, there are at least two features that matter. The traveling, which the more or less we travel, the more or less carbon footprint we generate, and the ICT infrastructure, like these things that we need in order to communicate the information. And in on-site conferences, traveling, because we travel physically, has a potential negative effect on carbon footprint, which is our concern, but also a positive effect typically on the knowledge transfer, because the interaction is more natural for us. The other way around, ICT infrastructure has a undefined effect until we measured on both these two concerns. And the better knowledge transfer out of experience in a systemic perspective, the better is also the research impact that we can have. So if we make this concern explicitly, we can then design a conference and measure the actual effect and see if the plan, like in this, was confirmed or not, and how much, and then we can make corrections. These with virtual conferences, the effects are kind of opposite. So we don't travel so much, so this has a potentially positive effect on carbon footprint. But also, out of experience, we see that not traveling and having a virtualized conference may have a negative effect on knowledge transfer and therefore on the longer-term research impact. So once we have these concerns, like knowledge transfer, carbon footprint, we define operational definitions for these metrics and associated metrics and KPIs or indicators, and then we apply and reuse and improve over time. And of course, this definition must be well defined and operational so that we can really map on values that we can collect, on data that we collect. And also, it is important to know that in sustainability, you might have concerns that are pertaining multiple dimensions at the same time. Like, for instance, flexibility. Technical flexibility is a property of the technology, but social flexibility, for instance, thanks to a flexible technology, I can choose to connect from anywhere and work from any place, anytime. It's a totally different definition, totally different data collection. So, and this is possible to detach and be very much focused on the type of things that we want to monitor in the sustainability goal. And this triggers a very simple pragmatic process in which from the decision map we identify the quality concerns, we associate these values that we want to collect and the metrics, we collect the measures, and there is the usual cycle in which we observe trends and then we go back to the sustainability goals. And we can define the sustainability goals in terms of this network of concerns. Example, back to our conferences, we can define the sustainability goal as a combination of minimizing the carbon footprint, maximizing the knowledge transfer, which is the goal of the conference, and balancing the technological investments in the ICT infrastructure. And you see that minimizing, maximizing, and balancing is something that, notwithstanding the number of attendees or the size of the conference, should provide a certain stable trend over time. And we carried out in a previous work some measurements, and here you see on the right-hand side the ideal situation in which hybrid conference should maximize the social impact, so the knowledge transfer, and at the same time balance the maximizing the environmental benefits and the economic investments with the same or a stable level of investments in technical, in the ICT investments. So if we see this as a model for sustainability, then we can design better conferences that would, in the hybrid sense, maximize the knowledge transfer and the impact on research. So the challenges related to better informed decision-making are threefold. First of all, in my research, architecture provides the ideal holistic view on the complexity of the systems, but still, again, representing time in the architecting decision is an open problem. Again, we change the architecture based on quality properties. Mapping these quality properties on the values that people and organizations have is an issue. So I see that we could identify values, like, for instance, ethical values, in the same vein as other types of quality. And the last is that I think is more important to observe trends within a certain type of systems rather than collect too precise measures, because there are too many variables And by observing trend, we always tend to use the same type of technologies. Last part is about education. So what competencies and skills do we need in our society for being able to develop systems that have a better sustainability impact? It's a no-brainer that due to digitalization, we need more experts in ICT and computer science. This is the picture recently, the last 5 years in the Netherlands, and the red bar, we see that the number of students is only increasing. A similar trend is also, this is a European perspective, is also in the ICT job market. In spite of the economic crisis, ICT is increasing in needs. We have a little bit of experience in trying to provide better education. On the left-hand side, you have master programs that we are involved in. On the right-hand side, you have training for companies and for PhD students. So if I reflect on the type of needs that are related to education and training as well, I see 3 aspects. One is that we should not only provide measures that are concrete, people like numbers, organization, governments like numbers, but be mindful about this being significant. It's not only to motivate, for instance, a business model, but it's really to fundamentally contribute to sustainability. The better organization will do that. The second aspect is that we did a study and follow-up studies coming up that see that organizations, depending on their own culture and on the sectors, they have different blending of hiring new talents and training of experts that are built expertise over the many years, and then by training them in the general sustainability competencies, they can also help the organization to leverage and to identify new business models. And at last, my experience is that organizations, any type of sector, they're hungry for good practices. I think we in research, we produce a lot of good results that are hidden in scientific publications. And we could provide them, disseminate this knowledge better as know-hows for the practice. We are trying to do that. Recently, we developed this open access, open source archive of tactics, and we want to take them one by one and measure them together with organizations, and anybody can contribute and it's given credits to this contribution. And on the right-hand side, the new Digital Sustainability Center at our university, we launched that officially in January, but this is really meant to create better synergy between the research, education, and practice. So I hope in this way that it's also easier for organizations that have important business to carry out, also to shift a little bit in the direction of sustainability. My last thoughts go to Ivica Klinkovic. Ivica taught me how to be a better researcher, how to be kinder, and because I'm a kinder researcher, I'm also a better one.